Hello, and welcome to our session, an introduction to the API and architecture of ArcGIS Runtime. My name is Rex Hansen, and I'm joined by Nick Furness. We're both product managers for ArcGIS Runtime, and we'll be the hosts on this journey. First, a quick rundown of the agenda. We'll start with an overview of the ArcGIS system and platform, and see where ArcGIS Runtime fits in. Next, we'll dive into the ArcGIS Runtime SDKs, the architecture, the capabilities, and see a host of demonstrations of functionality. We'll wrap up with a discussion on licensing and deployment, then finish with a demonstration of how to get started today. So the ArcGIS system is composed of 4 parts. ArcGIS Online, or our software as a service offering that comes with a number of applications. ArcGIS Pro, or desktop software for GIS analysts. ArcGIS Enterprise, server software used to host geospatial data, services, and analytics within a customer's infrastructure. And underpinning all of these parts is ArcGIS Platform, our platform as a service offering. So let's dive into the ArcGIS platform a bit further. ArcGIS platform is designed for developers. It includes location services that contain content or host capabilities such as base maps, geocoding, routing, and demographic data, etc. The ability for developers to host their own data and content, and a set of app builders to create web and native apps easily, as well as APIs for developers to build automation solutions, web apps, interact with services through open source or RESTful APIs, and notably for this session, ArcGIS Runtime SDKs to build native mapping applications. So let's dig into what ArcGIS Runtime is and describe a set of high-level benefits that make it valuable and unique within the ArcGIS system as part of ArcGIS Platform. Developers use ArcGIS Runtime SDKs to add map visualization and geospatial capabilities to native apps. This empowers app users to do all things spatial, from simple map display and navigation to editing and sharing of geographic data to advanced visual analysis. Now, ArcGIS Runtime delivers the best mobile experience in the market today. As it's built on native technology, Runtime can take advantage of GPUs and device resources to deliver high-performance, high-fidelity 2D and 3D mapping experiences. Runtime APIs are refined to give developers the tools they need to build solutions for simple and sophisticated workflows. ArcGIS Runtime SDKs power offline workflows. Runtime not only supports local access to a wide variety of vector and raster data formats, it takes advantage of the convenient tools and services within ArcGIS system to deliver data and packages for on-demand, pre-planned, and desktop workflows. It also includes local geospatial analysis tools to compare and modify geometry, locate, route, determine line of sight, visualize viewsheds, all designed to deliver complete 2D and 3D mapping experiences offline from local resources. ArcGIS Runtime SDKs support multiple platforms. They can integrate with the most popular developer environments, so our users, our developers, can use the programming language of their choice to deliver apps that target both desktop and mobile operating systems with confidence. And last, ArcGIS Runtime SDKs integrate with the ArcGIS system. We know the ArcGIS system includes ready-to-use data and services and provides powerful tools to create, manage, stylize, host, and secure geographic data, maps, and workflows. ArcGIS Runtime SDKs are specifically designed to work seamlessly with all parts of the system, from ArcGIS Pro to ArcGIS Enterprise to ArcGIS Online. Ultimately, Runtime is designed to deliver the best mapping and mobile experience possible, online or offline, 2D or 3D, across multiple operating systems and device types. So we've often been asked, why build a native application? There's amazing web technology available today, and you can build some highly functional, rich web applications that perform great on mobile devices or desktops. Why deal with the extra complexity? Well, we feel that only native applications deliver the best performance. Native SDKs allow you to get closest to the hardware you're running on, and ultimately, that will determine performance. You're not running within the sandbox of a browser or limited to the functionality the browser exposes. Not only are you using the Runtime SDK, but you also have access to other native SDKs that enable you to take full advantage of the device and its resources and peripherals. One of the notable benefits is the ability to debug fairly advanced scenarios and workflows with rich developer tooling. We've heard this reported by a number of our native developers, unable to achieve the same experience debugging in a browser. But perhaps the most important benefit is the ability to work offline, disconnected, and use local data and analytics. Our JavaScript API is great. It's a rich API, but it's designed to work online in fully connected environments only. ArcGIS Runtime is designed from the ground up to work in both connected and disconnected modes, online or offline, with access to local data and resources. So what ArcGIS Runtime SDKs are available today? We deliver SDKs for Android, iOS, Java, Qt, and .NET developers. We support use on Android, iOS, Mac OS, Linux, and Windows platforms. The development platform determines which operating systems we support. Runtime functionality is designed to be equivalent across all APIs and platforms. So how are we able to deliver consistency and high performance across all runtime SDKs? Almost all the business logic in ArcGIS Runtime is implemented inside of C++ in what we refer to as Runtime Core. That code is compiled on a number of architectures, x86, x64, ARM, and ARM64, and we make heavy use of graphics cards for rendering, leveraging DirectX, OpenGL, OpenGL-ES, and Metal. So we compile this C++ runtime core, and we target these operating systems listed here. On top of our runtime core, we provide a consistent and common API that each native API within our runtime SDKs use to deliver a consistent and natural developer experience. So if you're a .NET developer using the ArcGIS Runtime SDK for .NET, the Runtime API is going to look and feel like a native .NET API and developer experience. It doesn't look like the internal C++ API that we use. The important thing to stress when you look at this diagram is you don't pick an API based on performance. All the APIs perform very well because almost all of the work is being done at the C++ level and is being compiled down to native code, which is executing on the appropriate architecture. Now let's step through a summary of the functionality available in ArcGIS Runtime. Working with layers from services, this is where you're in connected mode, connected to the internet or a network where you can work with a server. A majority of these layers come from ArcGIS services: feature layers, raster layers, map image layers, tile layers, vector tile layers, scene layers, annotation layers. They may come from ArcGIS Enterprise services or ArcGIS Online or platform services. This includes feature services which deliver features, geometry, and attributes, raster layers from an image service, and tile layers that include base map imagery and content. In terms of OGC sources, we support KML, WMS, WMTS, WFS, and the latest standard API features. And one of the primary benefits of ArcGIS Runtime is access to local data sources. We support reading and writing features from and to mobile geo databases, geo packages, and shapefiles. Raster layers support a slew of raster file formats, such as GeoTIFF and Mr. SID. Of course, rasters can also be sourced from mobile mosaic datasets or geo packages. KML layers can come from local KML or KMZ files. We have near full spec coverage. And annotation layers for working with explicitly placed text as a feature class in a mobile geo database. And ENC, or electronic nautical charts, we support data stored in S57 with S52 symbology, and we have targeted support for S63 encryption. We can also work with local data as packages created by the ArcGIS system. Tile layers contain raster tiles of map data at a defined extent with levels of detail and can be created by ArcGIS Pro or export-enabled map services and distributed as tile packages. Vector tile layers contain tiles of vector map data generalized and optimized for display with custom rendering rules for dynamic symbology and labeling options. They can be created by ArcGIS Pro or export-enabled vector tile map services and distributed as vector tile packages. Scene layers contain 3D data in the I3S or indexed 3D scene specification to optimize storage, distribution, and visualization and use of 3D data. They can be created by ArcGIS Pro and distributed as scene layer packages. And with that, I'm going to hand it off to Nick Furness, who's going to walk us through a broad demonstration on the use of layers within ArcGIS Runtime.
Let's take a look at a few of the layer types supported by Runtime. We'll start with something really pretty straightforward, tiled layers. So tiled layers are great for things like satellite and aerial imagery, where you need image-based content that's static. In this case, it's JPEGs and PNGs. You can see as we zoom in and out, different levels of detail are downloaded from the service and displayed on the map. You can get really high levels of detail when you go all the way in. And of course, that means that you have many, many tiles of high-resolution data to download and display if you want to look at them at this level of detail. Of course, we support tiled layers offline with local tile packages, in this case a TPK. As I just mentioned, though, the more you zoom in, the more tiles of high-resolution data you need. So when you're dealing with TPKs and so on, very quickly you get to a point where adding extra layers of detail, levels of detail, as JPEG and PNG images, would start to build a very, very large tile package. So that's one of the limiting factors of tile packages when you're downloading them to devices, especially mobile devices that have limited storage. A step towards resolving that is vector tile layers. Here we're looking at vector tile layers online. Now you can see that these are drawn at the highest resolution the device can handle, no matter how much we zoom in. And as we zoom in, we see those full levels of detail available. Of course, because they're vector tiles, labels and so on are rendered upright, no matter what the orientation of the map is. And we can change the styles using the same content. Of course, using ArcGIS Online's vector tile style editor, you can create your own styles and consume those in the runtime too. So that's all handled by a vector tile layer when you point it at a service. You can also point a vector tile layer at a local tile package of vector tiles, a VTPK. Here we see the area of Washington, DC, and as before, we can apply different styles to this one set of tiles. So we've downloaded a single vector tile package of tiles, of the data, of the content, and we can display it in different styles. And as you zoom in, you still see all the rich detail that you would get in the full set of online tiles. And of course, they're all rendered at the highest resolution with dynamic labeling as well. Now, vector tiles can get into this level of detail without increasing their content as significantly as image tiles might. So whereas in San Francisco, we started to see blurry tiles and couldn't see any more content as we zoomed in, here we can see all this detailed content just from a single package on a device. So vector tiles offline can be a very efficient way to bring static data down to your applications. So these layers we've looked at so far are all static data, and of course that's really good for base maps, providing a reference for the rest of your map. But vector tiles and image tiles don't have to be just our base maps, they can be your data as well. Here we're looking at a set of features from a feature service that have been baked into a vector tile layer. Using ArcGIS Online, you can take a feature service and bake it as a tiled layer or a vector tiled layer. Here, of course, we're looking at the vector tiled layer. So we zoom in, we see all the detail, it's all rendered high resolution. But the one problem with this, although it's extremely fast, it is static data and it doesn't contain anything other than rendering information. As we tap on here, we can't find anything out about these individual features. So here's the original feature layer that vector tile layer was baked off. You saw it rendered a little bit slowly, but still really quickly. In this case, we're now taking advantage of something called feature tiles, where a feature service, rather than passing down individual features as individual JSON elements, can bake features into tiles of highly compressed binary data, PBFs, which the runtime can then decompose into individual features on the device. So we'll see as we zoom in, these have downloaded really quickly, they've got full detail on them, but now we can tap on them. We can get information about them. We can get the attributes from them, and individual features are represented here on the device. So this is kind of a magical best of both worlds technology here, where we've got a lot of the performance of vector tiles, but also the flexibility and individual feature identifiability of features. And of course, these are generated dynamically, so as your features change, your content on the map will be updated to reflect that, whereas vector tiles need to be recreated from scratch whenever your features get updated. This, of course, works for point, line, and polygon feature services and works across the Runtime SDKs. Now you've got features down on the device with the attribution, we can do other things with it, of course, rather on top of just displaying them in a pop-up. You can use the attribution to do labeling, and here we see the runtime labeling these rivers in Scotland on the fly. As we rotate the map around, the runtime recalculates the best place for a label and how to display the label based off labeling rules that are defined on the feature service. But sometimes you don't need this dynamic labeling. Sometimes you want to have very specific control over how the labels are positioned. And for that, we support annotations. So here we see the same set of data, but this time the labels are very carefully positioned by the designer of the map, the designer of the data. Specifically creates these labels, positions them, and you can see they're using reference scale here as well to get larger and smaller as the map zooms in and out. And as we rotate around, they stay static relative to the map itself. Now, annotations are extremely important in the utility space where individual features need to be annotated on the map in a very specific way. Users inspecting these features need to know exactly how to expect to see them on the map and get very specific information from them. So there's no scope for automatically recalculating on the fly. They need to be baked in ahead of time, designed essentially around the features that they annotate. Now we support annotations online and offline, feature-linked annotations where the content of the text is updated dynamically based off attribution of the linked feature. And you can edit those offline and online as well. Now, features don't have to come from a service. We've seen them coming from services here with the rivers and the tiles in Malibu. They can also come from a local shapefile. Here, this is a shapefile on the device, on the iPad. And as we zoom in, of course, they're rendered at the highest fidelity that the iPad display covers. And because they're attribution-based, we can do searches based off them. And furthermore, this is a shapefile. We can edit it directly on the device. We can add a feature here. And that feature is now part of this shapefile on the device. You can offload this shapefile, open it up in a tool like ArcGIS Pro, and get access to these features. We also recently added support for group layers. Now, group layers have been asked for a while. They've been supported by other ArcGIS tools, and we now support them in Runtime too. It does what it says on the tin, really. You collect layers together in groups, and you can control those groups as a unit. So, for example, we can turn off the trees, pathways, and project area all at once. Of course, we can still control each individual layer if we want to. But by having simple control over groups of layers now, you can write more sophisticated applications that are more useful to your users and with less code. And of course, less code always means fewer bugs. Related to group layers is a new type of layer called subtype layer. This was driven by the utility network and the utility space. And essentially, you add a single layer to your map, you point it at a single layer in the feature service, and it will interrogate that layer in the feature service to see what subtypes are available and add multiple sublayers to your map. Each sublayer represents one feature type within that source layer. What this means in practice is that Runtime can make a single request to get data from multiple layers from the service. And that's very, very helpful for utility network applications, but also has applications beyond that. So here we can see we've got a single subtype feature layer added to the map, but it has created multiple sublayers for service points, streetlights, switches, transformers, and so on, that have all been automatically added to the map. And as we pan and zoom around, requests are made for all those layers at once, rather than having to make requests against each individual sublayer, which can be a lot of network traffic and a lot of wasted effort. Let's step away from features now for a second and look at rasters. Runtime, of course, includes great raster support. Here we see an area of water just outside of San Francisco Bay, pulled down from a raster service with raster functions calculated on the fly, but it doesn't have to work with services. Again, the raster layer can access local geotiffs. So in the background, we have our imagery service, and overlaid on top of it is a more up-to-date geotiff of the local area. This, of course, is incredibly useful for a number of different use cases, including emergency response, disaster response, where you need to have the very latest imagery available to you. And of course, you can have that on the device, take it with you, and access it with or without a network. So let's talk a little bit about our support for OGC. OGC has a number of different layer types. Here we're looking at web feature service of building footprints. We've supported this for a while. Recently, we added support for a new OGC format or standard known as API features. Here we're looking again at feature data from Syria, in this case, street networks. And of course, because they're features, we can pull up attribution on them. And we've added support for API features recently, and we'll continue to add support as the standard evolves. Of course, we also support WMS services, in this case, weather patterns from the recent storm that hit the East Coast, and WMTS services, tiled services. Much like the tiled services we saw earlier from ArcGIS servers, WMTS allows for pre-baked tiles to be displayed on a map as well. We don't just support OGC service-based formats, we also support GeoPackage. This can be used offline. It's a single package that includes both feature and raster data. And of course, because these are all layers, we can reorder them, add them, remove them from the map, and you can see these features are drawn at the highest resolution the device supports. This is all from a single file, a GeoPackage file. We also support KML. It's another OGC format. In this case, we're looking at a KML file downloaded across the wire, but we also support local KML on the device. We also support editing KML and creating KML. In this case, this over-the-wire KML has network links in it, which dynamically update with the latest flight information. Here we see flight information in Europe, and of course, we're in a scene actually, not a map, so this is 3D data pulled down, dynamically updated from just a single KML file. It's literally 2 lines of code to add all this detail to your map, given the KML file source. Some other data formats we support are ENC, electronic nautical charts. In this case, we're looking at a very detailed map of an inlet and a port. Because this is vector data, we have a lot of control over dynamically rendering it. For example, here we're looking at where you could get to with a 10-meter draft. You couldn't actually get into the inlet. To get to a 5-meter draft, you can get into the inlet and over to the dock up to the top right. We get a 2-meter draft, you can see that boats can actually start to make it into the harbor there. And of course, because it's vector data as well, we can change the styling appropriately according to the ENC content and specs. Okay, let's just change tack really quickly and look at some more 3D stuff. We saw the KML file in 3D. Let's just look at feature tiling in 3D. We mentioned feature tiling before when we looked at the Malibu parcels. Here we have feature tiling in 3D looking at cities across the US. We saw how quickly that downloaded all these major cities across the US, and feature tiling is extremely powerful for getting this kind of data down to the device really quickly. Of course, once it's here, it's features, you can interact with it, interrogate it, and so forth. We also support more detailed services, such as an integrated mesh service. Here we see Girona in Italy being loaded from a service using the i3S spec. It's pretty detailed. As you zoom in, you can see they react by getting higher resolution data more appropriate to the field of view that we're at. And this is really great interactive 3D data. Now, of course, we don't have to hit a service. We also support this offline. Here we've got the same mesh stored locally on the iPad. And you saw how much quicker that loaded than from the service, because this is still fully interactive. And as we zoom in, we don't really get that delay that we did in getting the higher resolution data. You can see that the runtime only displays the data it needs to for the resolution it's at. That's all stored locally in the integrated mesh scene layer package. And the last thing I want to show really quickly is another 3D data type, point cloud data. Here we're looking at San Diego and LiDAR data collected from San Diego. As we zoom in, you can see how this data is updated and re-rendered on the fly with literally tens of millions, in this case over 100 million points, all displayed very quickly on the device. And we'll look at more of this later.
Great, thanks, Nick. Now in that demo, we saw use of layers in the context of a map. Now a map is a central component of ArcGIS Runtime and an important concept across all of ArcGIS. In Runtime, a map is a class that holds and defines how layers, geospatial content, is organized and displayed together in 2D. It contains layers that represent base maps to provide geospatial context, such as imagery or road features, and operational layers which contain subjective, dynamic, often changing content used in analysis and decision-making. The map also contains information about how layers are displayed, such as symbology or pop-ups, to display attribute information. So where do maps come from? Maps can be created in code, distinctly customized for a specific application that users can save to a portal as a web map or save locally. A lot of flexibility. You can create a map from a portal item. A portal item can reference a web map, which is a common document for storing map information and sharing maps across the ArcGIS system as a whole, not tied to a specific client or technology. Web maps can be created by ArcGIS Runtime, but are often created by web viewers such as the MapViewer or desktop clients like ArcGIS Pro, and shared via ArcGIS Enterprise or ArcGIS Online as portal items. ArcGIS Runtime can read and use them, and in some cases, write back to them. You can also create a map from a mobile map package created by ArcGIS Pro. A mobile map package consolidates maps and data into a single file and archive. They can be shared via a portal or the file system copied directly to a device. While a mobile map can reference online layers, the mobile map package is designed for local access, really for offline use. When it comes to offline mapping workflows, there are really 4 key workflows, and they all have pluses and minuses. It's important to understand the pros and cons and match them up with your desired workflow, and that'll tell you which one you should choose. First, you can author maps in ArcGIS Pro and publish to Online or Enterprise as services, or start with Online or Enterprise and use Runtime to take these maps offline using an on-demand workflow. This is where you decide at the time you want to go offline, the area you want to choose, the levels of detail, and then tell the server to prepare the data, which can take quite a bit of time. Then download the packages, and then you can go offline. Later on, you can edit and sync any changes to the data, not the map, but the feature data, and you can sync back to the respective feature service. Now, this is extremely flexible because you're allowing your users to decide what they would like to take offline, but that flexibility comes with a price, and the price is load on your services. So if you have 40 to 50 users going offline, your servers can generally handle an on-demand workflow. But if you have thousands of users trying to go offline all at the same time, perhaps at the start of a workday, then this workflow is likely impractical. For that type of scenario, we have what we call the pre-planned workflow. This is where you or an administrator decide the areas for your users, for your field staff to take offline. It could be 2 or 3 areas, it could be more than a dozen, but as soon as the administrator determines that, the server or services behind the map then prepare the area to go offline, and then store the packages per area on the server, waiting for users to select it at a later time. Of course, this workflow scales to thousands of users, and we've actually got customers that have over 20,000 users going offline every single day, and they're using this workflow to make sure their services scale accordingly. Next, you can author maps and services in ArcGIS Pro and share via packages. This is a very productive authoring experience. Pro is a great tool for authoring maps and scenes, and packaging process is simple, but it only supports read-only workflows at this time. The last one is let's build everything in code. We'll configure it all and set it up, symbology, layer properties, everything. It's highly flexible with access to the full breadth and depth of the Runtime API, but it's development intensive and less flexible outside the app that it was built. You know, if you want to change anything, you have to update your code or recompile your application and then redeploy it. I'll hand things back to Nick, who will walk us through a demonstration of map workflows with ArcGIS Runtime. Nick?
Okay, so let's take a look at maps in action. Here we are in ArcGIS Online. We've created ourselves a map with a number of different layers in it covering water distribution. Now, if I take a look in the URL, this has an ID on it. And to use this map in the runtime, all we need is that ID and a simple bit of code. We create a portal item that references that ID. We create a map object from that portal item. As part of the runtime, we set the map property of that to the map we just created pointing to that portal item. And if you then run this application, this is what you get. It's a fully interactive map based off that web map, base maps, the layer contents, accessible directly on the device. Of course, because it's a vector tile base map, you can rotate nicely and see the labels still oriented correctly. And that was just with a couple of lines of code. That's using a web map online. How about taking that web map offline? Well, the first thing you need to do is jump into the settings for the web map. So we created the web map when we saw it in the previous browser window. Now we're looking at the details for this item in ArcGIS Online. We can jump over to the settings tab. And if the layers in the web map are enabled for offline use, then there's an offline tab available to you here. And you can come down here and enable the web map itself for offline mode. We'll come back and look at this map areas bit in a bit. But what that looks like when we run it is the same web map, but now because it's been offline enabled, in this application I have the option to download it. I'm just going to click the download button. You could see that the runtime is making some requests off on the server. It's created a job to generate the geodatabase of the features, the operational data included here. That's already completed. It also kicked off a job for generating the vector tiles for the base map. So now we're just waiting for that to happen. We generated the geodatabase of features and downloaded it already. We're now waiting for the vector tiles to generate. As soon as that happens, we'll download those, and we'll have all the components we need on the device to display the web map offline. So now we can see the same detail, the same vector tile base map. We can zoom in and out, but now we've just got a limited area of the map. If we go back and look at the web map again, we see this Manage Areas tab here. We can jump in here, and this is where the pre-planned workflow comes into play. Here, the owner of the web map can define predefined areas that will be packaged up on the server and made available to download. Let's just take a look here at the Seeger Park area. So if we jump back to the application and look at a pre-planned workflow, again, here we have the same web map. We can navigate around it. We're in a connected mode right now. accessing the web map directly online. But we can go and query those areas. These correlate to the 4 we just saw in the browser window. I can click Seeger Park and download that. You can see how that downloads very, very quickly. It doesn't have to generate any content. It's just downloading what's already available on the server as configured by the web maps owner and downloads that for use offline.
Thanks, Nick. Next, let's take a brief look at a high-level class diagram for how you would work with maps and layers, as they're such fundamental components of the Runtime API. So we have our MapView, which is responsible for displaying the content of a map, so it is bound to a map. And a map has one or more layers, and there's a number of layer types, which we covered earlier in this presentation. Now, ArcGIS developers should be familiar with this diagram, as it generally follows similar object models we built in the past for working with maps and layers. So thus far, we've talked mostly about working with a map in 2D. Let's talk a bit about working with 3D. Similar to how a map represents 2D, a scene represents 3D and is a central component of ArcGIS Runtime and an important concept across all of ArcGIS. In Runtime, the scene is a class that holds and defines how layers, geospatial content, is organized and displayed together in 3D. It contains layers that represent base maps to provide geospatial context, such as imagery or road features, a surface that represents elevation sources to provide terrain, and operational layers, which often contain subjective, dynamic, often changing content using user analysis or decision making. The scene also contains information about how layers are displayed, such as symbology and some 3D specific properties, such as surface placement and underground navigation. So where do scenes come from? Similar to maps, scenes can be created in code and distinctly customized for a specific application. You can create a scene from a portal item. A portal item can reference a web scene, which is a common document for storing scene or 3D information and sharing scenes across the ArcGIS system as a whole. It's not tied to a specific client or technology like a web map. Web scenes are usually created by web viewers, such as the Scene Viewer, or desktop clients like ArcGIS Pro, and they're shared on ArcGIS Enterprise or ArcGIS Online as portal items, where ArcGIS Runtime can read and use them. You can also create a scene from a mobile scene package created by ArcGIS Pro. A mobile scene package consolidates scenes and data into a single file or an archive. They can be shared via a portal or the file system and copied directly to a device. While a mobile scene can reference online layers, the mobile scene package is designed for local access for offline use. In general, most layer types supported in 2D, or maps, are supported in 3D, in scenes. However, 3D brings with it a whole set of additional data sources, types, and options. Scene layers are optimized for display of 3D content in a scene. A number of types are available and supported in Runtime, such as 3D objects, which can be used to reference textured volumetric objects like buildings, integrated mesh, which represents a continuous 3D surface, often acquired by drone or satellite sources, point clouds, which represent LiDAR data, and points, basically point features cooked to be efficiently presented in a 3D context. Every scene has a surface that represents one or more elevation sources used to define terrain, used to provide topography in a scene. Sources include an image service with lurk-encoded tiles, a local tile package with lurk-encoded tiles, or a local raster with elevation information, such as a geotiff. Features are supported in maps, but can be enhanced in a scene to define how they are placed on a surface, whether symbols are billboarded or draped. They can use 3D model symbols to represent things like cars or trees, or leverage extrusion based on an attribute to communicate intensity or value. So there's a lot of benefits that are unique to 3D. If we add this to our class diagram shown earlier, we can see a similar structure. The scene view is responsible for displaying the content of a scene, so it's bound to a scene. And a scene has a surface and one or more layers, with additional layer types supported for 3D. Now let's take a closer look at an offline workflow that supports the use of scenes. Now in this demo, we're starting with ArcGIS Pro. We have a scene showing the region around downtown San Diego, California. The scene contains an elevation surface from a tile package with lurk-encoded tiles generated in ArcGIS Pro from a USGS digital elevation model. It also contains a tile package with image tiles generated from the ArcGIS Online World Imagery Base Map. And last, a LAS file or LiDAR data from the USGS containing 150 million points rendered by height using a default color scheme. I can use the Create Mobile Scene Package tool to generate a mobile scene package in MSPK from a scene and the layers it contains. We'll run the tool and create the package. Next, we'll write some code, use the Runtime API to open the MSPK and access the scene. We'll run the app, and we should see the same data that we saw in Pro in ArcGIS Runtime. Now, all this data is local. It's all within the mobile scene package. Note the last file was converted to a scene layer package and contains point cloud data before being included in the mobile scene package. You can see how quick and responsive the app is with such a large amount of data, and how the minute details in the data, such as buildings and construction materials, are displayed with extreme clarity. We'll note in the distance, the terrain and imagery, and the topography associated with our surface is also displayed for you to see. When it comes to analysis operations, there are certain analysis capabilities that come through services, such as geoprocessing services, network services for routing, closest facility and service area calculations, geocoding for place finding, and utility network for tracing. Work for this type of analysis is done on the server and returns results to the client. We can also take advantage of similar analysis using a local engine within Runtime's C++ core. This includes things like geometry to perform basic operations like distance, densification, and reprojection, but also local network and geocode operations, which can be used offline. For 3D specifically, we have a set of interactive analysis options such as line of sight, viewshed, and measure, all designed for exploratory visualization. I'm actually going to hand it back to Nick to cover a demo on routing analysis and use of our navigation API to build a turn-by-turn experience.
So here we'll see an address lookup to find a destination, and we'll get navigation from our current location to that destination.
In half a mile, turn left on West Cypress Avenue.
So what you just heard there was text that's output by the navigation API to the developer, and the developer can use a voice synthesis solution of their choosing to present that to the user. In this case, it's iOS's default voice readout. Now, this user interface itself is not provided by the navigation API, but some of the content within it is. This application is actually the open source Maps app provided by the open source apps team. But the 3.5 miles remaining, the 9 minutes remaining, and the 0 feet to the next maneuver is all provided by the navigation API.
In half a mile, turn right on South Center Street. Go southeast on South San Mateo Street.
So there the navigation API noticed that we had diverged from the planned route and had to recalculate directions, which it presented to us.
In half a mile, turn left on West Highland Avenue.
A couple of things worth noticing is we've got some pretty detailed maneuvers available. For example, here turn left and then turn right. You'll see how the map remains oriented up for your travel, and also how the little blue dot remains snapped to the planned route, even if the device's GPS is a little wayward. And of course, all of this functionality works online or offline, which, as expected, has proven to be a strong differentiator and selling point.
Thanks, Nick. Another capability with ArcGIS Runtime is augmented reality, available for production use today. We delivered this functionality a little over a year ago and continue to enhance where and when we can. AR is enabled for mobile platforms, for iOS and Android devices specifically. These capabilities are not designed or available for virtual reality, VR, or mixed reality, MR solutions. AR capabilities are delivered within Runtime SDKs that support iOS and Android, which means the Runtime SDKs for Android, iOS, Qt, and .NET. They are delivered as open source toolkits so developers can work with different hardware capabilities and the AR Kit and AR Core capabilities built into iOS and Android. And finally, when using ArcGIS Runtime on a desktop platform, you can use local server. Now, local server is like a mini ArcGIS server dedicated to the one runtime application that starts it. The Runtime Client app can start and stop the server and publish services. Local server is notably important for developers migrating from ArcGIS Engine to ArcGIS Runtime, because where Runtime doesn't have the capabilities of Engine, such as advanced analysis, direct connect to enterprise geodatabases, or use of file geodatabases, Runtime clients on desktop platforms, Windows and Linux, can use local server. Now, in general, local server is powered by geoprocessing packages created in ArcGIS Pro. You can string together multiple tools or use Python scripts to enable and automate a variety of workflows, then publish via local server and use in a Runtime app. Note that over time, the need for local server will diminish as Runtime Core gets more capabilities. So let's start to wrap up with a release timeline and discussion on deployment and licensing. The ArcGIS Runtime 100.x generation of releases stretches back to November 2016 with 100.0 and spans nearly 4 years to the current release 100.10, referred to as Update 10. We've targeted a wide variety of functionality to support the ArcGIS system in specific industries over that time. As functionality has matured over these 4 going on 5 years, and we've seen significant growth in the use of ArcGIS Runtime across the board. We've seen existing customers and partners migrate from older Esri developer technology to ArcGIS Runtime. We've seen many new customers come on board and add GIS and mapping to their native apps for the first time, and we've helped many customers transition from competitive technology to a more complete and robust platform. So after you build your application, there are a few considerations for deployment, both technical and business considerations. On the technical side, your development environment will often handle packaging the necessary components. But if you need additional information, such as metadata for the projection engine or inclusion of data, you'll need to add that explicitly. If using a local server, you'll need to choose the parts you need to deploy and possibly the packages you intend to use. On the business side, a few considerations. First, revenue-generating apps need a commercial deployment license. That license is included when using an API key or ArcGIS identity to access data or services as part of the ArcGIS platform anywhere in your runtime app. If you're not using the ArcGIS platform, you'll need to purchase a paid ArcGIS developer subscription. Next, review the functionality being used in your app and select the appropriate license level and extensions. We'll cover that in more detail in the next slide. But first, let's review the licensing options. Named user means ArcGIS Runtime is licensed with an ArcGIS identity as part of ArcGIS Platform, ArcGIS Online, or ArcGIS Enterprise. Most named user types include an ArcGIS Runtime license level. One named user can be used to unlock or license any number of ArcGIS Runtime apps. The runtime license travels with the user. Note, though, that a runtime license from a named user is only valid for 30 days, at which time a user must log in and renew the license. So named users are great for connected, partially connected, or short-term disconnected workflows. Alternatively, license string means an explicit ArcGIS Runtime license, usually purchased in deployment packs. The license string never expires and is usually embedded in a runtime app. Each license is counted per deployment, which means per app, per device available to a single user. License string is a great option for situations where named users are not available for an app, or the app needs to function offline for an extended, maybe unlimited period of time. So let's take a look at the capabilities included with ArcGIS Runtime license levels and extensions. There are 4 levels: Light, Basic, Standard, and Advanced. Light includes viewing maps, scenes, and layers as services and local data created by the ArcGIS system. This includes tile packages, vector tile packages, and scene layer packages. Light also includes routing and geocoding, both online through services and offline through a local network or locators. Basic includes everything in Light, plus an API to edit features and use the navigation API to build a turn-by-turn solution. Standard includes everything in Basic, plus access to additional data sources that are not part of the ArcGIS system. This includes geopackages, shapefiles, KML, and raster files like geotiffs and Mr. Sid imagery. 3D visual analysis is also included at this level. Also, use of local server is supported with Standard. Advanced includes everything in Standard and primarily focuses on enhancements to local server to enable access to geodatabases and advanced geoprocessing. As for extensions to runtime levels, StreetMap Premium delivers data in mobile map packages licensed by region. This data can be visualized and used for geocode and routing offline. StreetMap Premium can be added to or extend any level of runtime. Utility Network enables access to tracing analysis within the ArcGIS Runtime API. Currently, all utility network tracing takes place on the server, but the ability to call the Runtime API to initiate a trace requires the utility network extension. Again, the utility network extension can be added to or extend any level of runtime. The analysis extension can only be added to runtime licensed at the standard or advanced level. It includes native support for service area and closest facility operations on local network datasets. It also enhances support for local server to include 3D Analyst, Network Analyst, and Spatial Analyst GP tools. Great. So a complete overview of ArcGIS Runtime architecture, functionality, and licensing options. Next, I'd like to pass back to Nick for our last demo, which will help you get started developing with ArcGIS Runtime.
Now that you've seen everything that Runtime has to offer, how do you get started using it? Well, start off by heading to developers.arcgis.com. That's going to be your homepage for working with all developer tools. If you don't already have an organization account or a developer account, you can create yourself a free developer account and get started. You can use an organization account and access all the developer tools as well. And here on the homepage, we see some of the capabilities of the platform highlighted, but we're going to jump into the documentation page. Here on the documentation page, we can narrow down the various bits of documentation to just runtime, what's relevant to us as runtime developers. We'll come back to the mapping APIs and location services page later, but let's start off with one of our SDKs. I'm going to jump into the iOS SDK because that's what I'm most familiar with. And here we have an overview page. This is really actually a good highlight of what's available to you here on the developer site. We have some steps for getting started. We introduce you to our tutorials, which are a core component of the developer site. We have sample code as well. Sample code is slightly different to tutorials. In a tutorial, you're walked step by step towards a goal of understanding a particular piece of an API. In sample code, you have that single piece of an API in use. You can see how to use it, how to code around it, and so on. Beyond that, we have open source toolkits. These add components to the Runtime SDK that don't really fit in the core SDK, stuff like legend displays or scale bars. The AR components are also included in these toolkits. You can jump through to the Get Started page here. You see that's the next page here in the table of contents on the left. And you're invited to review the system requirements, install and set up your API, get an API key, we'll show that in a bit, and then jump straight into a tutorial. So between these two pages, you can just get started with the SDK. In iOS, we have two options. We could do a manual install of downloading the SDK directly and installing it, or we can use CocoaPods, which is a popular package manager. Each SDK focuses on whatever's appropriate for that API, for that environment. .NET and Android, for example, use package managers extensively. Beyond that, I invite you to focus on the release notes. Here we have various conceptual sections, and each section has tutorials, discussions that are SDK specific. And at the bottom, we have a license and deployment section. It's important that you review these, as these will cover how you actually get to use the runtime in your applications, how to license it, the various options for licensing it. For example, you can license your app with a license string. Here we see some sample code. Since I'm in iOS, I can switch between Objective-C and Swift. And at the bottom, you'll see your light license key, which is the free license key you can use for a large amount of capabilities, as was covered already. Beyond that, we can look at the API reference. Now, the API reference is where you get into the real weeds, where you see all the individual classes and the methods on each of the classes, and you can jump in and explore and learn about how a specific class works. For example, graphics. There's a description of graphics. You can see the methods, the properties, the class hierarchies, and so on. So this is where you get into the actual API weeds. Going back to the main documentation page, I just wanted to cover the Mapping APIs and Location Services guide. This is more of a conceptual guide. You can see here it talks about maps, data, visualization, geocoding, searching, demographics, and working offline. In each of these sections is a specific topic that introduces you conceptually to what the platform can do for you. And everything's accompanied by interactive demos, of course, in JavaScript, but all the capabilities are shared by the runtimes as well. Now, you can pick a runtime of your choice and see snippets inline in the pages as you learn about the capabilities of the platform. Each of these pages includes examples, and these are just to reiterate the topics that were covered in the page. And then you're invited to try tutorials that are related to the topics that you've covered here. So these tutorials will drop you back into the SDK page of your choice, and you'll be able to go through step by step and learn about that particular capability. For example, how to create a map. We start off by setting up your IDE, adding a MapView to the UI, and you can see the code included here that you'll need to paste into your application to get it working. And we'd walk you through step by step and introduce you to the API. Now, important for working with the ArcGIS platform are API keys. And so we'll jump back up and look in the dashboard really quickly. Once you're logged in with either an organization account or a developer account, you have your dashboard here, which gives you access to API keys, Auth2 applications, all the layers you might have created under this account. And here we see I have an API key set up. I could copy this API key, drop it straight into my application in one of those tutorials, and get started.
Thanks, Nick. I'd like to close with a slide on ArcGIS Runtime session tracks at this year's Developer Summit, where more detailed information on ArcGIS Runtime is available. We'll have the standard product-focused sessions on each Runtime SDK product, and a set of functional sessions that apply across all Runtime products. That includes this session on the Runtime API and architecture, but also use of the ArcGIS system, authentication, working with maps and data online and offline, and notably a focus on support in the utility sector. We invite you to explore these other sessions at your convenience. Before you go, remember to provide your feedback for this session by clicking on the session survey link directly below this video. And with that, I'd like to thank you for joining us and thank you for your interest in ArcGIS Runtime. Great. Thanks for joining us. My name is Rex Hansen. I'm joined by Nick Furness. We're both product managers for ArcGIS Runtime. We're going to take you through the Q&A portion of this section. Thanks for joining us. We've got a couple questions out in the live Q&A. We're going to start at the top. First question is, we have noticed very laggy user experience and even crashing when using Android, the Android API, if rendering and interacting with 10 or more feature layers. Is there anything we can do from an API usage perspective that enhances the performance? Nick, you want to take that?
Yeah, sure. So, yeah, I mean, first of all, there isn't really a hard limit on the number of layers that you can and can't use. I would expect that 10 layers would work pretty well, but we do have a performance considerations document. If you go to the SDKs homepage and on the left-hand side, look under programming patterns, you'll see a performance considerations document that includes a lot of hints and tips, optimizations that can guide you through getting the most out of your application and avoid any pitfalls that could be causing problems. I'll paste the link in as a reply to this question, but also if you have specific questions around this, I do encourage you to come to the Ask Our Experts. We can look into your specific case and see if we can find someone there from the Android team who can help look into that.
Great. So the next question, do you plan to support a React Native SDK? It's a good question. We have this listed out on our ArcGIS Ideas site as part of our community. It's got a number of upvotes. It's been a popular question over the last year or so. We don't have plans right now to support a React Native SDK. However, we do have customers that have successfully built out bindings, React Native bindings on top of our ArcGIS Runtime SDKs for Android and iOS, and delivered applications for production use in that context. Now, while we do support the use of the ArcGIS Runtime SDKs in that context, we don't actually support the bindings themselves. So that might be one option for you to consider in the near term. Longer term, though, obviously we're interested in any projects or efforts that would support us maybe embarking on an endeavor to support React Native. So feel free to provide us with feedback on the ArcGIS Ideas site, or actually through our Ask Our Experts showcase, as well as through the forums. Whatever way you can contact us to let us know about your workflows that require this. Next question is, does Android allow for more of a shared code base between iOS and Android? I'm sorry, does Xamarin allow for more of a shared code base between iOS and Android? A little like React Native does, would Xamarin be a better option? If so, in order to make use of native APIs and functionality? Well, so Xamarin, the ArcGIS Runtime SDK for .NET supports Xamarin, and Xamarin is a powerful technology for cross-platform, especially for mobile use. So with native Xamarin, iOS and Android apps, you can share business logic and create individual UIs. With Xamarin Forms, you can also abstract UI and share UI logic. Now, this is also based on the fact that we support .NET Standard. And so .NET Standard will really get you where you want to be. It'll provide a simpler, cleaner experience going forward. So Xamarin does provide, today, Xamarin does provide a great option for cross-platform work and sharing code between iOS and Android. Next question, is there a way to cache features or layers in general in a more persistent storage rather than just in memory? Data consumption is a limitation for us. We're using the Android Runtime API. Nick, do you want to tackle that one?
Yeah, I can have a go. So in general, no, we don't allow you to say just take a feature service that you're hitting and sort of dynamically cache content that's pulled down for display on the map on the device in some sort of persistent storage. But what we recommend in cases like that is to take a look at some of the offline workflows that we have, whether you decide to pull data down from the device, from the service as offline data, or whether you can distribute it in some other way, perhaps as a tile package or a vector tile package, and potentially do that, while you're on Wi-Fi before you head out into the field. So we have a few different offline workflows that are aimed at addressing that kind of question But in terms of just dynamically caching to disk, no, we don't support that in runtime at the moment.
Cool, great. Next question is, what support for web map pop-ups is included in runtime? Nick, you want to tackle that one as well?
Yeah, I can jump on that. So we read the web map definitions and expose pop-up definitions from a web map on each feature layer. There's a pop-up definition property on the feature layer. You'll get the feature layer out of the operational layers of your map that you load from a web map. And then we have a pop-up manager class that helps prepare that for you to present it. In some of the SDKs, in the iOS SDK, for example, we actually have a UX component that can then talk to that pop-up manager and talk to the pop-up and interrogate pop-up definitions to display something for you. In some of the other SDKs, you have to do a little bit more work to work with that pop-up manager and actually present the pop-up contents. But we have full support for the pop-up model and exposing it to you.
Great, thanks, Nick. Next question is, as new versions of Runtime, ArcGIS Runtime come out, what workflow do you recommend for maintenance of older applications that were developed with older versions of ArcGIS Runtime, for example, 100.4 to 100.9? I can take this one. So when newer versions of Runtime come out, a couple things to pay attention to is the new functionality that comes out as part of the system. That includes not just ArcGIS Runtime, but different capabilities that roll out with ArcGIS Pro and ArcGIS Enterprise and available through ArcGIS Online. But also our product lifecycle. And so on our support site, we list off our product lifecycle for ArcGIS Runtime releases. In general, we have a 4-year lifecycle for every runtime release. That's 1 year of general availability, 1 year of extended support, and then 2 years of mature support. And the qualification for those levels really dictates what type of, what expectation you should have for being able to utilize ArcGIS Runtime in that context. After 4 years, the runtime version is retired. Then it's no longer officially supported. I would probably pay attention to the different categories associated with the product lifecycle to determine when you need to start migrating your application to the next version, in addition to factoring in new functionality that you need to take advantage of, and the other ArcGIS system components that you're dependent on, such as Pro and Enterprise, or even Online. So a couple things to keep in mind there. Next, the next question is, any idea what might be causing this error? So a little troubleshooting. So the looks like mobile map package version is not supported. Mobile map package version not supported 4.0. So this issue is likely a problem with a mismatch between the capabilities that are included in a mobile map package, and that might be data formats and sources, as opposed to the ArcGIS Runtime version that you're using to try and read and utilize that mobile map package. So with the mobile map package version 4, we introduced support for online layers in a map document, as well as a scene document. And so if you try and work with a mobile map package of a version that's higher than the supported version of Runtime, you will get an exception, an error when loading the mobile map package. Now, we do have some documentation in our API reference that talks about the different versions of our mobile map package and what was added, what support was added in that context. And with the mobile map package class, when you load the mobile map package, regardless of whether it succeeds or not, you will get a version, and so you can check that. Now, what's probably happening here, I suspect, although always good to stop by our Ask the Experts showcase to get more details, but what I suspect is happening here is that you're using a version of Runtime prior to update 10 and trying to load a mobile map package that was created with, say, Pro 2.7 that includes online layers. And so we added support for online layers in ArcGIS Runtime update 10. So if you try to use any prior version, like update 9 or prior, you would probably get this error message. So something to keep in mind. Next question is, will feature layers be supported in 3D and when? Nick,
yeah,
this one.
I think we only have time for this one really quickly. The answer is yes, they are already supported. If it looks like they're not, you may be hitting a case where you've got a layer configured with a renderer that we don't fully support yet in runtime, and that might make it a little difficult to see the data popping up, but feature layers are supported.
Great, and I think it looks like we're about to run out of time, so there's a number of other questions here, great questions here on .NET Core, working with web apps and portal items, local server, Xamarin Forms, and Maui. Like I mentioned in this session, we've got a number of different product focus sessions later this week. We've got a road ahead on Thursday and basically a full session of live Q&A on Thursday afternoon. So feel free to join those as well. Come to our Ask the Experts showcase to talk specifically with some experts in these different products. So I encourage you to participate there as well. But thanks again for joining our session, and looking forward to talking and speaking with you further and meeting you later. Thank you.